All right, parametric surface area of revolution. Once we know the parametric version for ds, and we know the general formula for surface area, which is 2 pi times radius ds, then we're set for doing these types of problems. So let's just jump right in. The curve x equals 2 sine t, y equals 3 cosine t, and t goes from 0 to pi, is rotated around the y-axis. Find the surface area. So first up, let's look at what this looks like so we can get a decent drawing of it. So let's see, we've got x equals 2 sine t. And y is 3 cosine t. So we get that, which is, let's see, not showing up. Here we go. And we're going from 0 to pi. So that gives us that. So it gives us half of an ellipse. So I'm going to copy that down over here. We've got half of an ellipse. And we're going to rotate it around the y-axis. So we're going to get this sort of egg shape. So let's see. First up, let's work out our ds, and we also need to know our radius. So the ds is going to be, let's see, dx dt is going to be 2 cosine theta, or 2 cosine t, and dy dt is going to be 3 derivative cosine is negative sine, like that. So our ds is going to be square root of, let's see, if I square this and then I square that, what I wind up with is, let's see, 4 cosine squared t plus 9 sine squared t dt. All right, so that's my ds. And what about my radius? Actually, before I do that, is there anything I could do with this to make it any nicer? I'm not sure if this is going to make it nicer or not, but we could do this. 4 cosine squared t. I'm going to break this 9 sine squared t into 4 sine squared t plus 5 sine squared t dt. And this right here is just going to become 4. Yeah, because you factor that 4 out and you've got 4 times 1. So that's our ds. But what about our radius? Well, let's see, the radius in this case, if we're rotating around the y-axis, the radius is going to be x. And x is 2 sine t. So our surface area is going to be 2 pi integral radius ds. So 2 sine t square root of 4 plus 5 sine squared t dt. And we're going from 0 to pi. So a good question is, how can we do this integral? This is worse than any integral I would throw at you that I actually made you do. I'm not really sure right off how we would do it. I think if I'm just going to mention this, we're not going to do this, but I think what we could do is replace this sine squared with cosine squared with 1 minus cosine squared t. If we did that and then we let u equal cosine, we could do a u substitution and turn this into something that I believe then could be done with a trig substitution. So this thing's definitely possible to do, but it's going to get ugly quickly. So we've got that set up. let's just plug this into Desmos and figure out the surface area. Let's see, Desmos. I'm going to put this in, let's see, 2 pi integral from 0 to pi of 2 sine t square root of 4 plus 5 sine squared t dt. And it won't surprise me if this doesn't give us an answer. Yeah, it does not like that. It probably needs some help figuring out how to parse this. First thing I'm going to do is I'm going to put some parentheses around here. Yeah, putting parentheses around those, that helps it out and gives it 67.67 as an approximation. All right, let's look at this next example. This curve is rotated around the x-axis. Find the surface area. Okay, so again, let's do dx dt and dy dt and come up with our ds. Dx dt is going to be 3 minus 3t squared. Dy dt is going to be 6t. Then I'm going to square all this. Get 36t. I square this, I get, let's see, 9. Let's see, twice the product. 3 times 3 is 9, times 2 is 18. Same thing's happening here that happened on a previous example. Let's see, plus 9t to the 4th. When we do our ds here, when I add these two guys up here together, the 36t, which that should actually be a 36t squared. When I add this onto here, all it's going to do is change the sign of this 18t squared. So I'll wind up with 9 plus 18t squared plus 9t to the 4th. And there's a dt on the end of this. And I can factor this into 3 plus 3t squared squared. And then the square and square root undo each other, and we're left with, I don't need the square root anymore, 3 plus 3t squared dt. All right, so that's my ds. Now we're rotating around the x-axis, so that means that the radius is going to be y. Why is that? Well, you take whatever your shape is you've got, when you rotate around the x-axis, your radius is y. So we get our surface area. It's 2 pi integral of radius times ds. And we're going from 0 to 1. Okay, so this is actually an easy integral to do. We'll distribute that 3t squared across there. So we'll get 9t squared plus 9t to the 4th. And now we can just integrate. This becomes t cubed, the 3 on front. This becomes t to the 5th, with the 9/5 on front. We're going from 0 to 1. My two favorite numbers to plug in. Because you plug in the 1, you just get 3 plus 9/5. You plug in the 0, you just get zeros. So let's see, 3 plus 9/5, that's 15. Plus 9 is 24. So it looks like that ought to be 48 pi over 5.